Alright guys, in the last video we were talking about the 6-port injector port, and we were really focused on tubing lines only. So where's the tubing coming from, where is it going to, and there were 6 different ones that we had to kind of juggle up and figure out what goes where. So in this video, we're going to talk about what's behind that stainless steel circle. I told you that's what we were going to do in this video, and that's what we're going to do. I'm sticking to my word for a change. So we're going to take off this stainless steel round circle. We're going to pull it off, and there are things that are going to happen in the back. Well, this is a 6-port injection valve. And valve means that it will direct the flow of something. That's what valves are. So in the 6-port injection valve that we are referring to, here we go. Here is the 2 main terms that we use. So before we go in and take it pieces and parts and how things are operating, we got to know a little bit about the language and a little bit about the terminology. So first off is the bypass mode, and the second one is the main pass mode. So as you can imagine, if something bypasses, it really bypasses the injector altogether. Now, I do want to say that this injector port is going to be found with a manual injection or with an auto sampler. It does not matter, because if we are manually injecting sample, we're just taking the spot of the needle and the auto sampler tray. That is really it. So the 6-port injection valve still has to be there. I've got to still inject the proper amount of sample into that injection valve, so that way eventually it can then take that sample and take it on into the machine. So this valve is there no matter what. I don't need the actual auto sampler, and if I don't use an auto sampler and I have a manual injection instead, I'm going to be injecting it eventually into this same valve. So I don't want you to make any kind of misinterpretation of that. That 6-port injection is always going to be found on LC systems, whether you have an auto sampler or not. So in that injection valve, you're going to see a bypass. And the bypass is just really the idea that the machine's on, the machine's flowing, it's pumping mobile phase through, but I'm not injecting anything at all from the auto sampler tray. It is just simply mobile phase is running, mobile phase is going through the injection valve, mobile phase is making its way to the column. Nothing is happening at all, period, as far as my sample goes. So that is the bypass mode. Then that valve will change. And that valve will change into what we call the main pass. And the main pass is actually going to connect the sample to the mobile phase. It's going to allow that mobile phase to go into the sample compartment and then pick up that sample and carry it on through the HPLC instrument. And that means eventually that mobile phase is going to carry that sample into the column. So that is the main pass, because that's really why we're mainly using the LC system, and that's just the proper term that comes along with it. Now that valve on the inside, there is a valve, right, that switches back and forth, back and forth, back and forth. It closes off one route, opens up another route. Then when it gets done injecting, it closes that back off, goes back to mobile phase. So it constantly switches back and forth between the bypass and main pass in order to get this action to complete. Well, that valve has a seal, and like most of the seals inside of a pump, the seals inside of the analytical head, the seals inside of this valve, these seals are pH dependent. And the pHs are really between 2 to 9.5. So this means, hello, this means again, on top of the LC system, I should not have a bottle of straight up hydrochloric acid. On the HPLC system, I should not have a bottle of straight up NaOH solution. Chances are those pH values are going to be lower than 2 and higher than 9. So yet again, the whole reason of not to use concentrated acids and bases as mobile phases. If I have to add acid or if I have to add base to a mobile phase, I'm going to prep it myself. And I'm going to mix it in the mobile phases myself. and I'm going to place that in line D. That's already buffered. It's already ready to go. I should never require the LC system to do this for me only. So never be pumping HCl all the way through. Never be pumping sodium hydroxide all the way through. Potassium hydroxide all the way through. Sulfuric acid all the way through. Phosphoric acid all the way through. No strong acids. No strong bases. Anything that has a pH greater or greater than 9.5 and lower than 2. I do not want those to reach the actual injection valve at all. So yet again, more proof why we should be making those mobile phases ourselves. All right, so now let's take a look and go deeper into this bypass and main pass. There is a motor, of course. That motor is kind of the valve that we're referring to. That motor does switch back and forth, back and forth, back and forth, back and forth. So that motor can get stuck. That motor does have consumables. That motor does need a little bit of troubleshooting and maintenance. So this is kind of the rabbit hole that we're now going to go down into in order to figure out how to do all of this. Here's a schematic. This schematic says before the start of the injection sequence and during an analysis, the injection valve is in the main pass position. In this position, the mobile phase flows through the autosampler metering devices, the sample loop, the needle, and it ensures that all parts are in contact with the sample are flushed during the run. So this will help the carryover. So what's happening here in these schematics that you're getting ready to see, you have an arrow that points this way. All right, so this is the mobile phase from up above. So that mobile phase is going to go, there we go. And this is going to be in spot number 1. All right, so in spot number 1, the mobile phase is going to come in, and normally it's going to eventually go to the column. And in the column, we are eventually going to have it to leave out of the injector site. And it's going to take the mobile phase or the mobile phase and sample into the column and into the detector at that moment. All right, so we've already talked about spot number 1. We've also talked about the metering device or the analytical head. So here is the metering device and the analytical head. And as you can see, there is a seal, and that seal can get worn out. And we've talked about replacing seals. The way that we replace the seals on the main pumps are the way that we replace the seals on the metering devices as well. We can also have access to that plunger. That plunger or that piston is just like all the others. So that looks for damage, looks for scratches, we look for chips. And if we see any of that, we want to replace that as well. So just like we do on the pumps, this is like a little mini pump. So why shouldn't we do it here too? And we do. So that has a tubing line that goes here at the bottom and one here at the top. So we've also talked about that top line. So where does that come from? What's its purpose? We said that that is the needle seat, and the needle is right here. And up on top, we have a tubing line that goes round and around in order for this pump to suck back and suck sample up out of the HPLC containers. And then eventually this sample is going to go into the HPLC system, and we've got to flush everything. We've got to flush everything. So the idea here is, how do we do this? How does the machine do it? And how do we ensure that no cross-contamination or carryover is happening? All right, so in spot 1, or I'm going to say in this schematic, in step 1, when we use an LC system, we turn on all the power, we get the juices flowing, we get the mobile phase pumping into the system, and this is the setup that's happening at that moment. So when the sample sequence starts, we are in the bypass position. And this is just really, the pump is activated, the pump carries the mobile phase in, and it goes through the injection valve and it goes straight out. This is the bypass position. So mobile phase is going to go in, and then out of port number 6, and then it goes into the column. That's what this is. Notice that the tubing lines are not connected anywhere else. That's the purpose of the switching valve. So the reason that we call this the switching valve is that it switches, and what happens is that this thing will rotate, and it will rotate, and I'll hear that, or then it will go back, and it will go back into the original location. But that switching valve is controlling the flow of the mobile phase as we begin to inject samples. That's what this is all about, okay? So this is the bypass position. No samples are getting injected. Mobile phase goes in spot 1. Mobile phase leaves out of spot 6. Nothing comes in contact with the samples. Nothing is getting sucked up by the needle. No sample containers are venturing over to the needle seat for it to sit there and allow the needle to puncture it and suck up sample. None of that is going on at all. Okay? So then what happens here is that we get an activation that we want the machine to inject sample. All right, so the grabber arm, here's the grabber arm, is going to grab the grabber. The grabber's coming. He's going to throw you in the van. Stay away, unless you want to go to his basement. So the grabber is going to go out, and the grabber is going to get the sample container, and the grabber is going to bring that sample container back. All right, so there's the sample container, and I've got a nice little pink solution. Yay! All right, so the analytical head now pulls back. Now, if you look at port 1 and port 6, mobile phase is still flowing through. It's still not coming in contact with my samples, right? So mobile phase is still pumping. Not a big deal, not an issue. This is just the moment of the machine loading the sample up. That's what this is. It's drawing the sample into the flow path, so that way the mobile phase can grab a hold of it at some point and flush it on. So the analytical head, that piston's going to pull back. And when that piston pulls back, it's going to suck sample out of that container. As you can imagine, if that is not leak free and I get little drip, 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 I get a problem. Because that pressure needs to have that proper pressure, or I'm not sucking up the right amount through the straw. I mean, you all have been there. You all have probably put a straw into a soda cup and then sucked up on that straw and been like, what's the deal? I can't get any liquid up out of here. Well, that's because that company, Starbucks or Chick-fil-A, has given you a straw that has a slit in it. It's damaged. It's not building up pressure. And if you can't build up pressure, you can't suck solution up and out. Well, just like the LC auto sampler, if you get leaks that are on this back end from the seals or from damaged pistons, you're not going to be able to get liquid up and out of those sample containers. You got to make sure that those are performing legit. That means replace the seals and replace the pistons if needed. If you see leaks here, you got to do some consumables. You can't just watch the leaks and be like, oh, it'll be okay. It's not going to work. Because if that leaks and if it can't build up the proper pressure and it's not sucking up the right sample amount, then even in your standards, when you build a calibration curve, it's not going to be sucking up the same amount every single time. Who knows what you're going to get for a sample amount? 20 microliters, 18 microliters, 15 microliters, 25 microliters. Who knows? Pay attention, folks. Leaks are bad. Be a plumber. All right, so piston pulls back. Pink solution goes up into the top, into the tubing lines up here. All right. So now that the sample is loaded, now what goes on? All right. Well, here the switching valve switches and it rotates. And it opens the gate. Open sesame! And now the mobile phase can make its way in, and now the mobile phase can go through the motions of actually getting your sample and carrying it on through. So what you're going to see in this image is the idea here that mobile phase is now going to go in. we have a main pass position that has now underwent in the injection valve. So it is connecting port number 1 to, guess what, port number 2. That makes numerical sense. So the mobile phase is going to go in. The mobile phase continues through the injection port. The mobile phase ventures up into the analytical head. The mobile phase goes through this tubing line that did have your sample loaded up in it. I don't know how much was in there. It really depends on what you've told the machine to suck back, but there was sample in there. And then that mobile phase continues to go through, and it goes through the needle to kind of rinse all of that out too at the same time. And then it goes through the needle seat. And when it goes through the needle seat, it goes into spot number 5, and then it makes its way to spot number 6, where then it goes out. Folks, the mobile phase flushes the entire chambers, analytical heads and all of the tubing lines that held your sample. That mobile phase is there to pick your sample up and carry it on. But at the same time, mobile phase continues to push through all of these tubing lines, and that way it can ensure that everything really truly is out of there that needs to be out of there. So in order to watch this 6-port injector do its job visually a little bit better, you're going to see an external video that I'm going to post that shows this internal injection valve in operation a little bit better. So please watch that external video. I've said that before. I'll say it again. Please watch that external video to see visually what's happening inside of these injection valves as we begin to work with them. Now, while we are talking about this discussion, we've already mentioned it already, there is a seal in the metering device. And that analytical head or that metering device, again, that's the stainless steel piece that's up here to the side, that has the piston in it, that has a seal in it, and we want to make sure that that actually is sealed leak-free, so that way we can get that nice suction that we want out of that system to pull our samples up and out of those containers. So those things do have to be replaced. And if you don't visually see leaks, there are signs otherwise that can tell you that it probably needs a little bit of work. So the auto sampler reproducibility, the RSD of these systems, begin to plummet if your analytical metering devices are not doing their job the proper way. So what this means is that in some of the samples, when I begin running instrumentation, when I begin running real samples legit for companies, what will happen is that we will have a sample container, and that sample container will be an HPLC sample container, and there'll be solution in here. That solution will be injected maybe 10 times. Who knows? But we'll go to that same sample vial. I know, I already told you I don't like this, but okay, if we do it like once or twice in the mornings, that'd be okay. We just get really good septa with really good HPLC containers. And we allow that system to inject samples from that same container over and over and over. Now, if you don't want to do this, you can load up the same sample in 10 separate HPLC containers. That is also okay if you get weirded out with your septa. In that way, you are still injecting the same sample over a course of 10 different times. And you do an average and you do a standard deviation and you calculate an RSD. Remember, RSD calculations are going to take your standard deviation and you're going to divide by your average, and that will give you a relative standard deviation. And if you multiply this by a 100, that will give you a percent RSD. So it really just depends on how the company wants you to report that data. Most of the time, they will want percent RSD though. So that will give you a little insight. Yeah, we multiply by 100 after we do the calculation. And if that value is extremely high, that percent relative standard deviation, we want this value low. If this value is higher than what the company likes, then that means your precision is bad. If your precision is bad, then that means that leaks are probably present. And those leaks can come from a number of different things. They can come from the pump, they can come from the injection valve, but they can also come from the analytical head. And I don't want you to forget that idea, because there is a piston in there, there is a seal in there, and that is kind of building this pressure up and injecting the sample amount. It should be the same sample amount over and over and over and over and over. So that analytical seal, very important. In order to get to these and in order to change them out, very simple to do. I'm going to disconnect the tubing lines that are from the top and from the bottom. Remember, the one on top is from the needle. The one on bottom is from the injection valve. I'm going to disconnect those two tubing lines. And then what will happen is that I will take an Allen wrench or a hex wrench and I will go in here and loosen these two screws. Those two screws are holding the analytical head in place. So I'm going to take those out. I've highlighted those in yellow, and then I'm going to remove the entire stainless steel piece altogether. When I remove that stainless steel piece, just like on the analytical head, there's going to be a screw here and there's going to be a screw there that's going to hold this device in place. So I'm going to loosen these two things up. By loosening the two things up, I can then separate the two compartments from each other. I saw that with an analytical pump head. I'm seeing it here because in a sense, this really is a pump head too at the same time. On the inside, surprise, surprise, I get the same thing. I see this kind of guard that's going to be located. I saw that in the pump, and I saw a piston that's also going to be in there. I saw that from the pump as well. So I'm going to inspect those. I'm going to make sure that those look good before I do anything else. Look for damage. Look for kind of wear and tear. Look for dry rot. Make sure that everything looks okay and decent. And then if those look pretty okay, then I'm going to focus on the seal itself. So the seal is going to be down here on this round circle part that kind of pokes out to you when you look at an LC in person. Well, that is the piece that's going to have your pump seal in it. So I'm going to go here and I'm going to zoom into that area. And just like the pump, I'm going to see a seal that's going to be here on the inside. So that seal is going to be just like the other times. There's a nice little tool that you can purchase, or you can use the end of a plunger, or in this case, it says a small screwdriver. I don't recommend a small screwdriver, but it's there if you kind of want to go that route, I guess. But you're going to pop that seal out. This seal does get gunked. The seal does see some sample. So, we hope that it doesn't see a lot of sample. But it does show some mobile phases, and it's going to get used. It's going to get worn and torn. It's going to get dry rotted over a course of time. It's just going to wear itself out like everything else. So we're going to pop out that old one, and then again we just push in the new one. You can do that with your fingers or with the help of the tool if that's what you want to do. On top of that new seal, you're then going to place the piston guide on top and just make sure it seats in the proper location. And then the top half of that analytical head is going to kind of slide down on top, and it's going to line up with those holes. You're then going to put the plunger back in. Again, make sure you inspect that for damage. Now's the time to replace those if you have to. And then you're going to take these lock screws and you're going to place them inside of the analytical pump head, and you're going to screw them back together. That locks the system back in place, so that way you get a nice little tight fit between the two halves of the analytical pump. Or not the analytical pump, the metering device. So with that said, once this kind of container gets situated back together, you place the entire system back on the auto sampler, and now your metering device is ready to take these two long screws, and you'll just insert them back into the sides, tighten them back up with the hex wrench, and you're good to go. Connect the two tubing lines back together, and now you get a hopefully analytical head that is going to be able to have the suction power that you need with very few leaks that you're going to see now, and your reproducibility is going to be much, much better than what it was before. The metering device prices here are kind of the pistons. Again, similar pistons to use in the pump. These are going to be ordered just like in the pump section that we talked about. That's not a big issue at all. Again, it often comes with the seals. If you replace the piston, you're going to replace the seals too at the same time. Or you can just replace the seals and order those by themselves. Here's the piston. 100 microliter for 1100, 1200, 1260, 1120, 1220 pumps. And you're going to see those $198, $200 a pop. This particular one only requires one, but keep in mind that your analytical pump head, that requires two. So just really depends on what your your maintenance is going to be, but this really only requires one and not two of them like the pump did. All right. So in the next video, we're going to focus on the needle assembly. This is something else that we can do some troubleshooting, maintenance, pieces and parts on. We're going to talk about the way the needle is designed and what I can and cannot do as far as the user goes inside of this system. So that's what we'll talk about in the next video.